Hello everyone, I am Divya, your math facilitator. In this video, we shall discuss chapter 1 of class 7 integers. This would be an introductory video where I would explain you the basic concepts of this chapter, and we have already discussed few concepts in the earlier video, in the part 1 video. So do watch that video too so that you'll have a continuation of this chapter and you'll get the video by clicking on the I button. Let us discuss about the properties of integers, and in that firstly let us discuss properties under addition. Okay, properties of integers under addition. And properties, as you know that you have learned few properties in your earlier class also. What are those? They are nothing but closure property, commutative property, associative and distributive. Yes, so the same properties we shall learn under addition, subtraction, multiplication and division for integers. Okay, so the first property is closure property. Now we are talking about closure property under addition. Okay, so what is it? Now the property states that if A and B are two integers, okay, since we are talking about integers, if A and B belong to integers, okay, integers we denote it by the letter capital Z. So if A and B belong to capital Z, then A plus B should also belong to capital Z. Okay, since you are learning about properties of integers under addition, okay, so I am taking only additive symbol. Okay, so A plus B should belong to integers. Now let us check with an example. Now let A is equal to minus 5, B is equal to 2. Okay, now what is A plus B? A plus B is nothing but minus 5 plus 2. Yes, so what is minus 5 plus 2? When you have a negative integer and a positive integer, what do? You subtract. Now 5 minus 2 is 3, and the sign of this answer will be the sign of the bigger number. Now in these two numbers you can see that 5 is a bigger number. Yes, now which sign does 5 have? 5 has a negative sign, so the answer also has a negative sign. So minus 5 plus 2 is nothing but minus 3. Now minus 3 belongs to integers. Do you agree? Yes, so we can say that this condition is satisfied and integers are closed under addition. Now let us talk about commutative property under addition. Okay, so what does the commutative property state? So if A and B are two integers, okay, if A and B belongs to integers, then A plus B should be equal to B plus A. Okay, that means you add both the integers in any order, but the answer you get should be the same. Okay, so now let us take some example. So let A is equal to 3 and B is equal to minus 2. Okay, both belong to integers. Now let us see what is A plus B. A plus B is a LHS side. Okay, so A is nothing but 3 plus B is minus 2. Okay, now 3 plus minus 2. Now it is one positive integer and one negative integer. So what do? You subtract. Okay, so it is nothing but 3 plus into minus 2. Yes, so 3 minus 2 is 1. Clear? Now let us see what is B plus A, the RHS. Okay, so B plus A is equal to, now B is minus 2 plus A is 3. Okay, one negative and one positive, what do? You subtract. So the answer is 1. And what is the sign of the answer? You see that among both the numbers, 3 is greater and 3 has a positive sign. So this one also has a positive sign. Okay, positive sign you did not mention it, but negative sign it is very much necessary that you mention it. Okay, so 1 or plus 1 means the same. So you can see that LHS is equal to RHS. Both the answers are 1. So you can say that commutative property holds under addition for integers, or you can say that integers are commutative under addition. Now let us talk about associative property of integers under addition. Okay, so for this the condition is if A, B and C are three integers. Okay, and now you can add these three integers in any order, but the answer you get should be the same. Okay, then we say that integers are associative under addition. Okay, so that means firstly you will add A and B, and for this sum you will add C. Okay, otherwise you will firstly add B and C, and for this sum you are adding A. Okay, in whichever order you add, but the answer should be the same. Okay, now let us see, let us check with a example. So let A is equal to 4, B is 3 and C is -1. Okay, now let me take the LHS side. LHS is what? A plus B plus C. Okay, here A is 4 plus B is 3 and plus C. C is what? C is -1. Okay, plus -1. Clear? So now firstly we have to solve the brackets. So 4 plus 3 is what? 7. Simple addition. Yes, and now plus into minus is minus and you have a 1. Okay, now 7 minus 1 is 6. Simple. Now let us check for the RHS. Okay, now RHS is what? A plus B plus C. So A plus B plus C. Now substituting the values of A, B, C. A is 4 plus B is 3 plus C is what? C is -1. Okay, now 4 plus, firstly we have to solve the brackets. Yes, so it is 3 plus into minus is -1. Okay, now this is 4 plus 3 minus 1 is what? It is 2. Now this is 4 plus 2 is 6. So you can see that LHS is 6 and RHS is also 6. Okay, so this is 6 and RHS is also 6. So you can say that integers are associative under addition. Now let us talk about additive identity and additive inverse of integers. Okay, so firstly let me give you few examples. Suppose what is 3 plus 0? 3 plus 0 is 3. Yes, now what is -2 plus 0? -2 plus 0 is nothing but -2. Do you agree? Now what is 247 plus 0? It is again 247. Yes, now what is -13 plus 0? It is nothing but -13. Yes, now tell me what is 0 plus 120? It is nothing but 120. Tell me what is 0 plus -30? It is nothing but -30. Yes, that means if you add 0 to any number, what is the answer you are getting? You are getting the same number. Yes, let us generalize this. Now you are adding 0 to any number, the answer you are getting is the same. Yes, or in this way you are adding it and the answer you are getting is A. Okay, the same integer A. Now A belongs to integer, so this condition is satisfying. Yes, so we can say that A plus 0 gives you A or 0 plus A also gives you A. So 0 is called additive identity of integers. Okay, that means you add 0 to any number, it gives you the same number again. Clear? Now let us talk about additive inverse. Okay, now let me take few examples like 42 minus 42. What is the answer? It is nothing but 0. Yes, minus 35 plus 35. The answer is 0. 419 plus 419. Okay, minus 419 plus 419. The answer is 0. Now what is happening here? You are adding two numbers and the answer you are getting is 0. 0 is nothing but what? It is additive identity. Okay, in general you are adding a number A to another number minus A. Okay, that means you are adding an integer to another integer and the answer you are getting is 0, which is additive identity. So in these cases, these two integers A and minus A are called additive inverse of each other. Okay, so A is called additive inverse of minus A and minus A is called additive inverse of A. Okay, so when A plus minus A equal to 0, then A and minus A are called additive inverse of each other. Okay, in this case you can see that minus 42 is the additive inverse of 42 and 42 is the additive inverse of minus 42. Okay, here also minus 419 is the additive inverse of 419 or 419 is the additive inverse of minus 419. Now tell me what is the additive inverse of 312? It is nothing but you will just change the sign. Yes, you will write 312 as it is, but here you have a plus, so you will write minus here. Okay, so that when you add these two things, the answer you get should be 0. Okay, now tell me what is the additive inverse of 41973? Okay, now I want the additive inverse of 41973 and I want the answers in the comment section below. So do answer in the comment section. Now let us talk about closure property under multiplication. Okay, so till now we have seen what are the properties of integers under addition operation. Now let us see what are the properties of integers under multiplication operation. Okay, so firstly let us talk about closure property. Now what is the property? As we have already discussed, if A and B belongs to integers, yes, now A into B should also belong to integers. Why did I take multiplication symbol? Because we are talking about closure property under multiplication, so the product of these two numbers should also belong to integers. Okay, so let us check with an example. Now let A equal to 5 and B is minus 2. Okay, now what is A into B? A into B is nothing but 5 into minus 2. Now we have already learned how to multiply integers. How do you do that? Firstly you will multiply these two numbers. Okay, so 5 2s are 10. Okay, and here for 5 you have a plus symbol sign and for 2 you have minus sign. So plus into minus gives you what? It gives you minus. Okay, so I already told you that 1 plus and 1 minus will always give you what? It gives you minus in the answer. Okay, and if you have 2 minus or 2 plus, the answer will be plus always. Okay, so if you are multiplying two negative integers or two positive integers, the answer will be positive, and if you are multiplying a positive and negative or negative and positive, the answer will be negative. Okay, so here you can see you are multiplying one positive and negative, so the answer is negative. Okay, but you can see that minus 10 belongs to what? It belongs to integers. So the property is satisfying, so we can say that integers are closed under multiplication. Now let us talk about commutative property of integers under multiplication. Okay, so the condition is if A and B belongs to integers, then A into B should be equal to what? A into B should be equal to B into A. The same property for addition, what did we write? We wrote as A plus B should be equal to B plus A. Do you remember? So now for multiplication, you will just change these signs. Okay, so addition becomes multiplication. Clear? And this property, let us check it now. So let A is 2 and B is minus 3. Clear? So now what is LHS? LHS is A into B. Now what is A into B? A is 2 and B is what? It is minus 3. Yes, now what is the answer? 2 3s are 6, and as I already told you, plus into minus gives you what? Minus. So the answer is minus 6. Be very careful with the signs. Don't forget to check for the signs. Okay, so it gives you completely wrong answer if you don't consider the signs. Now let us check what is B into A. Now B is what? Minus 3 into A is 2. Okay, now 3 2s are 6, again minus into plus gives you what? Minus. Okay, so you can see that the two answers are same. That means LHS is equal to RHS. So we can say that integers are commutative under multiplication. So this property holds good for integers. Now let us talk about associative property. So what is associative property? If A, B, C are three integers, okay, so what is the property? You should multiply A, B, C in any order, but the answer, the product you get should be the same. Okay, so if you multiply these three integers in any order, the product should be what? It should be same. Okay, so A into B into C should be equal to A into B into C. The same property we have learned for addition. Do you remember? So now firstly you will solve the brackets and then this product you will multiply with C. Okay, here firstly you will solve this bracket and then this product you will multiply with A. Okay, so let us take some examples. So let A is equal to 2, B is 3 and C is minus 1. Okay, so now the LHS is A into B into C. Okay, so what is A? A is 2 into B is 3. Okay, into C is minus 1. Clear? So 2 3s are 6. Solving this brackets first. 2 3s are 6 into minus 1. Okay, so firstly you will multiply these numbers. It is 1 into 6 is 6. Okay, so 6 into 1 is 6, and here you have a plus. Plus into minus gives you what? It gives you minus. So the answer is minus 6. Now let us take the RHS. A into B into C. Okay, so here A is 2 into B is 3 into C is what? Minus 1. Clear? So It is nothing but 2 into 3 into 1 is what? 3, and plus 3 into minus 1. So plus into minus is minus. So it is 2 into minus 3. Now again 2 3s is 6, and plus into minus is minus. So the answer is minus 6. So you can see that LHS is equal to RHS. So we can say that integers are associative under multiplication. Now let us talk about the distributive property of integers. Okay, so what is it? If A, B, C are any 3 integers, okay, so what is distributive property? It is nothing but A into B plus C should be equal to A into B plus A into C. Okay, now if you see here, this A is distributed to B as well as this A is distributed to what? C. Okay, so A into B is the first term. You have a plus in between, plus A into C. Clear? So now let us check this property. Let A equal to 1, B equal to 2, C equal to minus 1. Okay, simple numbers. Now what is LHS? A into B plus C. This is LHS. Let us check what is the answer of LHS. Now A is 1 into B is what? 2 plus C is minus 1. Okay, whenever you have negative integers and when you have a plus sign, so you have to write this number within brackets. Okay, why? Because if you don't write brackets, so this is how it looks. Okay, and you might have a confusion in solving. So whenever you have 2 signs, you should always write brackets. Okay, so that you will have some clarity. Clear? So this is one basic rule which will not be in your textbooks. So this is 1 into 2 plus. Now firstly you have to remove this bracket, and how will you remove? By solving these 2 signs first. Now it is plus into minus is minus. Okay, minus, and you have a 1. Okay, so now it is 1 into 2 minus 1 is 1. Clear? So 1 into 1 is 1. Okay, once you solve what is there in the brackets, then you don't have to write the bracket. You will just remove the brackets. Clear? Now let us see what is RHS. RHS is A into B plus A into C. Okay, A is 1 into B is 2 plus A is 1 into C is what? It is minus 1. So as I said, when you have 2 signs in this way, so what you will do, you will just write a bracket so that they don't mix up, there is no confusion. Okay, so now 1 into 2 is 2. Since you solved it, you will not write the brackets here. Plus 1 into minus 1. Okay, now let us multiply it. 1 into 1 is 1, and plus into minus is minus. Okay, so the answer you got is minus 1. But since plus and minus are side by side, so you write a bracket here. So it is 2, plus into minus is minus 1. Okay, so 2 minus 1 is 1. Now you can see that LHS is equal to RHS. That means distributive property holds good for integers, and this property helps you in solving the problems. Okay, finding the solutions very easily. Now when we were discussing the properties under addition, we spoke about additive identity, and now let us speak about multiplicative identity. Okay, so let me give you some examples. So what is 3 into 1? 3 ones are 3. Okay, now what is minus 25 into 1? 25 into 1 is 25, and this is minus into plus, so it is minus 25. Clear? Now what is 1 into minus 16? Yes, so 1 into 16 is 16, and you have a plus into minus, so it is minus 16. Yes, so you multiply 1 with any number, but the answer you are getting is the same number again. Yes, so let us generalize this. So A into 1 is giving you what? A into 1 is giving you A. Okay, here also A into 1 is giving you A. Or 1 into A is also giving you what? A. 1 into A is giving you A. Okay, in general you multiply 1 with any number, the answer you get is the same. So here 1 is called multiplicative identity. Okay, so you multiply 1 with any number, but the answer you get is the same. Okay, so 1 is called multiplicative identity. Now let us talk about multiplication by 0. Now let us take examples like 31 into 0. What is the answer? It is 0. Yes, anything multiplied by 0 gives you what? 0. So minus 145 into 0 is what? It is also 0. That means you multiply 0 with any number, the answer you get is 0. So let us generalize. If A is an integer and you are multiplying it with 0, the answer you get is what? 0. Yes, or if you multiply 0 into a, still you get the answer as 0. Clear? So if you multiply any number by 0, the answer you get is 0 itself. Clear? And if you multiply any number with 1, then the answer you get is the same number itself. Clear? Now let us talk about the properties of integers under subtraction. Okay, so now under that first property is closure property. So what is the property? If a and b are two integers, then a minus b should belong to integers. Okay, since we are talking closure property under what? Under subtraction. So you subtract these two integers to get an integer, okay, as an answer. So if it was closure property under addition, you wrote this, a plus b should belong to integer. And if it is closure property under multiplication, you wrote this, okay, a into b should belong to integers. Now a minus b should belong to integers. Now let us check. Okay, so let a is equal to 2 and b is minus 3. Okay, now what is a minus b? It is nothing but 2 minus 3. Since two signs are side by side, you put a bracket. Okay, you write a bracket. Now here it is 2 minus into minus is what? Plus 3. Okay, so the answer is 5. Clear? Now 5 belongs to integers, so you can say that integers are closed under subtraction also. Now let us talk about commutative property of integers, okay, under subtraction. So what is the condition? If a and b belong to integers, then a minus b should be equal to b minus a. Okay, that means you subtract the integers in any order, but the answer you get should be the same. Okay, so now let us take some example. Let a equal to 1 and b is minus 5. Okay, so what is LHS? LHS is a minus b. So a is 1 minus b is what? Minus 5. Yes, so this is 1 minus into minus plus 5. So 1 plus 5 is 6. Okay, so now let us check what is b minus a, the RHS part. Okay, so this is b is minus 5 minus a is what? 1. Okay, when you have two negative integers, when you have to solve this, when there are two negative integers, what do? You just add these two integers. Now 5 plus 1 is 6 and you write a minus sign. Okay, so it is 6 and minus 6. You know that 6 is not equal to minus 6. Yes, so commutative property does not satisfy for integers under subtraction. You take one more example and try to prove that commutative property does not satisfy for integers under subtraction. Now similar to commutative property, even associative property does not satisfy for integers under subtraction. So I want you to take an example and tell me if integers are commutative under subtraction or not. Now let us talk about the properties of integers under division. Okay, so what is closure property? If a and b are two integers, then a divided by b should also belong to integer. Okay, simple. Since you are talking about division property, so you will write a division sign here. Yes, so now let us take an example. Let a equal to 5 and b is minus 2. Okay, so now what is a divided by b? It is nothing but 5 divided by minus 2. Now tell me, is 5 divided by minus 2 an integer? No, it is not an integer. It is not an integer. Okay, it does not belong to integer. So we can say that closure property does not satisfy for integers under division. Okay, similarly commutative property and associative property also does not satisfy for integers. So take an example in this way and check for yourself and tell me if these properties are satisfying under division or not, and let me know in the comment section below. Now let us talk about division by 0. Yes, so if I want to divide any number by 0, suppose if I want to divide 5 by 0 or if I want to divide 10 by 0, what does this mean? Now for example, if I have 5 chocolates and if I want to divide it among 0 people, is there any meaning to my question? No. So if there are 5 chocolates, it's okay, but if I want to divide among 0 people when there is no one to divide, then what am I thinking about? So the question itself is meaningless. And here also you have 5 but you want to divide it among 0. Yes, this is nothing but you have to divide 5 among 0, which means that this itself is meaningless. So you cannot divide anything by 0. Okay, now for example, if you have 0 things and you want to divide among 5 people, okay, understand the difference. Here you are dividing 5 by 0, here you are dividing 0 by 5. Okay, for example, if I have 0 rupees, That means I have nothing with me. Now I want to divide these 0 rupees among 5 people. So how much does each of them get? Yes, so if there are 5 people, 1, 2, 3, 4 and 5. And how much I have? I have 0 rupees. Now if I want to divide whatever I am having among these 5 people, how much will each of them get? This person gets 0, he gets 0, 0, 0 and 0. Yes, when I have nothing and when I have to divide it for so many people, so I give them 0, I give them nothing. Okay, so this answer is 0. Okay, so when you want to divide 0 by anything, the answer you get is 0. Okay, since with this example I hope you understood. Now when you have something but you want to divide it among 0 people, so the question itself is meaningless and this is undefined. Okay, so such meaningless questions you call it as undefined. Clear? Now 0 divided by something gives you 0 and something divided by 0 is undefined. I hope this is clear for you, and if yes, give this video a big thumbs up, like it right now. Now if I want to divide any number, any integer by 1, what happens? So for example, if I want to divide 249 by 1, what is the answer? It is nothing but 249. Suppose if I want to divide minus 115 by 1, the answer is minus 115. Yes, so anything divided by 1 gives you what? The same number itself. Yes, so anything, suppose a is an integer and if you are dividing it by 1, the answer you get is again a. Okay, the similar thing you can write it in this way. So a divided by 1 always gives you the same integer a. So today's DIY question, do it yourself question is, I want you to list out all the properties of integers. Okay, so list out all the properties of integers and find which are satisfying for integers and which are not satisfying for integers. And I also asked you to mention few answers of questions in the comment section below which I asked during the session. Okay, and also write the answer of this also in the comment section below. Just tell me which properties are not satisfying for integers. Okay, and I hope this video is very helpful for you. You like this session, you were very much involved in this session, so I want you to show your love towards this channel by subscribing to this channel. So do like this video, give it a big fat thumbs up. Also share this video to all your friends and don't forget to subscribe so that you will get notified whenever we are posting a new video. And thanks for watching.